Okay, so we're going over median, and last year I found, well, actually 2 years in a row now, I have found that finding median is a challenge for a lot of students. So if this is something that you get right off the bat and you're 100% sure that you are good on median, then you probably don't need as much detail as I'm about to give you. But for a lot of you, I think that going through it to this specificity is really helpful. So in our fill in the blanks up here at the top, we have the median is the midpoint of a distribution. And when we say midpoint, we mean the literal middle of the distribution. So median is like a location in the distribution. It is the number such that half of the observations are below it or smaller, and half are above it. So our first example is going to be Joey. Joey's first 14 quiz grades in a marking period are right here for us. We're going to find the median, and I've listed it out with a lot of detail. So this top row is your observation or your observation number. And the bottom row is going to be your quiz score. Now it's not filled in yet because we need our quiz scores to be in order from least to greatest, and just to save us a little bit of time, I'm just going to do that for us. So our first observation is 74. Then 75, 76, 78, 80, 82, 84, and our eighth observation should be 86, 87, 90, 91, 93, 96, 98. And we want to find the number such that half of the data is below and half of the data is above. So we have 14 observations. What is half of that? 7. So we're going to go 1, 2, 3, 4, 5, 6, 7. That means that our median is not the 7th observation. It is in between the 7th and the 8th observation, because half of the data needs to be to the left and half needs to be to the right. So now if you count it, 1, 2, 3, 4, 5, 6, 7 observations are to the left. So going this way, there are 7 observations. And if we count again, 1, 2, 3, 4, 5, 6, 7 observations are to the right. So it is the literal middle. Well, there's a formula to find the median when it's between two numbers. So you do the two numbers, 84 plus 86, divided by 2. In this case, you could probably do it without that formula, because what number is in between 84 and 86? 85. So sometimes it's easy and you're just going to be able to know in your head what the median is or what the number between is, but sometimes you'll need to use this formula. Okay, that one's not bad, right? Next up, a random sample of 19 employees at a large company was selected. Here are the salaries in thousands of dollars for these employees during 1 year. Find the median. So I will give you the order. it is 28, 31, 34, 35, 37, 41, 42, 42, 42, 47, 49, 51, 52, 52, 60, 61, 67, 72, 75. So I'm going to find the middle of this distribution the old school way. So the way that I was taught median was you start at the 28 and you cross it off. And then you go to the 75 and cross it off. And you move back and forth until you find the middle of your data set. And doing that, I get that our middle value is 47. You could also just cover the values, use your finger and move in. And that will help you find the middle. But in this case, our median is 47. It is actually in the data set. Now we have to verify that the same number of observations are to the left as to the right. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. You're hanging in? Was that a yes? Yes? Okay. So then we go from getting a data set to getting graphs. So instead of getting a list of data, we get a graph. And at this point, I think that it is appropriate for us to learn the shortcut. So you can calculate the location or the position of the median using this formula in the box. Now, it does not give you the median. It gives you the location of the median. You have to be really careful that you keep that straight. It tells you where the median is at. It does not tell you what the median is. N stands for your number of observations. So in this formula, N is your total number of observations. So the dot plot displays scores of 21 statistics students on a 20-point quiz. Find the median. Okay, so if I'm finding the position of the median, I usually just call that the POM, P-O-M. I'm going to take the number of observations, 21. I'm going to add 1, divide by 2. What does that give us? What do we get? 11. So that means our median is the 11th observation. Our median is the 11th observation. So we're going to go to our dot plot and we are going to count up. You always count up. So what do I mean by that? I'm going to start at this lowest dot. I'm going to count 1, 2, 3, 4. Start at the bottom. 5, 6. Drop down to the bottom again. 7, 8, 9. Drop down to the bottom. 10. Your median is this middle dot. On what quiz score? What quiz score is that? 19. So the median in this data set is 19 points. In this one, I probably should have said the median is $47,000. Okay, so let's verify this whole position thing worked for our other data sets just to make sure. So position of the median, I forgot to do one thing. I want to verify that this is the middle, so I'm just going to count the dots really quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are to the right. Okay, position of median on number 2. We had 19 employees. We add 1. We divide by 2. What does that one give us? What is it? 10. So our median should have landed at the 10th observation. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that one worked. And then lastly, let's double check for Joey's quiz scores. We had 14 scores. Add 1, divide by 2. What do we get this time? 7.5. So what this means is that the location of the median is literally in between 7 and 8. So this means between 7th and 8th observation. That 7.5 literally means in between. It is halfway from the 7 and the 8. So anytime you get a 0.5, that means it's in the middle. Are you okay on that one? Okay, so now we know how to do a data set and a dot plot. The next one is this stem and leaf plot. Data on the caffeine content of popular soft drinks in milligrams per 8-ounce serving are displayed in the stem plot. Find the median. What important piece of information are we missing? I swear, they mow this lawn every day. What do we need on this stem plot? Nobody knows? The key. Gold star if you said that. So I know the key because I know this problem, but without the key, how do we know if this is 1.5 milligrams, 15 milligrams, 15,000 milligrams? We don't know. So to read this, let's go 3 bar 5 is 35 milligrams. So step number 1 is we need to know the number of observations. Does it tell us? No. So we got to count the leaves. Did anybody count the leaves yet? Okay, what did you guys get? Say again. 38. So position of median is 38 plus 1 divided by 2. 19.5. So that means that this is between the 19th and 20th observation. So you go to the stem and you start at the left, because that would be the bottom, and you count up 1, 2, 3, drop back down to the left and count up. Were you guys able to find it? Was that a yes? So it should be between the third and fourth 8. So that would be 28 milligrams. If you use the formula, that would also give you 28. 28 plus 28 divided by 2 is 28. Okay, the last one is the most challenging one. The graph below shows the histogram of the salary distribution for the Philadelphia Phillies during the 2008 season. Find the median of the distribution. Well, there's an issue with this one because it doesn't give us any exact values. What this first bar is telling us is that 9 players made between $0 and $2 million. What goes there? Sorry, I'm just going to write 0 to 2 million. So this, and the scale at the bottom is really weird. I don't like the way that they did their scale. But this first bar is telling you 9 players were 0 to 2 million. 3 players were 2 to 4 million. Is this making sense how you read this? Yes. So the first thing that we need to do is find the number of players that is represented in this histogram, which means you go over and you count the number of players in each bin. I'm going to pull somebody's stick for that, so make sure that you're doing it. You are finding the number of players in this histogram. You got about 30 seconds. $20. $10. $5. Okay, goes to Hannah. Yes. 25 players. So now we use that to find the position of the median. You have 20 seconds to find that, and I will pick somebody else's stick to tell me what position it is in. You will tell me what position it is in. $10. $5. Okay, that one goes to Ashley, but she learns at home, so hopefully she knows what it is. Emily. 13. So it is in the 13th position. Well, this one's interesting because we don't have like individual observations to count. So what we do is we figure out what bin the 13th observation is. So this first bin has 9 observations. This second bin takes us to 12 observations, which means that this third bin must have the 13th observation. So I'm going to highlight that. This is the bin that holds the 13th observation. That is where your median is located. So this is the disadvantage to a histogram, is that it doesn't give you specific values unless you have the data set. If all you have is the graph, you only know the frequency in each bin. So how we're going to write the median is, so this is 0 to 2, 2 to 4, so that means this one is 4 to 6 million. So I'm going to write 4 million less than or equal to median less than 6 million. Or you can write the median is between 4 and 6 million. This is more accurate though. Remember, when you do a histogram, it's the lower value that the numbers equal and the upper value is a less than, because it can go all the way up to 5,999,999, but 6 million belongs to the next bin. Does that make a smidgeroo of sense? A little bit? Okay, so now we only have one more problem in this median set. So hopefully now, no matter what kind of problem they give you, whether it's a complete data set, a dot plot, a stem plot, or a histogram, you feel comfortable finding the median. So now we just have to learn one other thing about the median. So recall Joey's quiz scores from problem 1. What was the median? So I'm just going to go back. It was 85. Now they want us to find the mean. So you're going to add up all of these quiz scores and divide by 14. Go. I'm going to pick somebody's stick for it. Add all the quiz scores. Divide by 14. Roughly 10. Three, 2. Okay, it goes to Zion. 85. All that work for the same number. So for this set, his median and his mean are the same. Now suppose Joey has an unexcused absence for his 15th quiz and he receives a score of 0. Find the median and the mean again. So I'm going to add this 0 onto the front of the data set, and I'm going to find the position of the median. So 15 plus 1 divided by 2 tells me that the new median is in the 8th position. So now starting at the 0, I'm going to count to the 8th position. So I get that the new median is 84. So having a quiz score of 0 did not affect our median very much. Our median went from 85 to 84. Essentially, it moved the median to the left by 1 position. Now, let's find the new mean. And actually, it's pretty quick because all you have to do is take that number that you got last time and divide it by 15 this time instead of 14. Because we didn't add another quiz score, we got a 0. So now divide that number by 15. 79.3. So what they're wanting you to recognize here is that the median did not change by very much, but the mean did. You went from a pretty strong B to hanging on to a C plus for your mean. Your median, it hardly had any effect. So this has a special property, and how you describe it is called resistance. So this says, what property of measures of center does this illustrate? We're writing the median is resistant to outliers. The median is resistant to outliers. So to give you a good description of what that means outliers. Resistant means outliers don't have a strong effect on the median. So remember, an outlier is an unusual point. If you have an outlier, it's not going to change your median very much because median is resistant. But it will change your mean. Your mean is not resistant to outliers. So I am going to bring around the homework that goes with this. Okay, bye, distance learners.